Good morning, ladies and gentlemen. My name is Nathan. I work at a startup called StackPath. We are currently in a closed beta, and we'll be exiting that within the next couple weeks, and we will have our first major public product out at that point. I am what they call an acqui-hire. I was originally with a company called MaxCDN, which was purchased, and so that's where the bulk of this particular talk comes from, is our experience at MaxCDN at deploying HTTP2 at a global scale and across, 20-odd POPs throughout the world and several hundred servers. Before I get started on this, I'm going to take a moment to share. I want to publicly thank Valentin for his wonderful talk on HTTP2 yesterday, especially because it was on the negatives and the downsides of HTTP2, which, ordinarily at a conference like this, you're not allowed to have a negative talk. Everything has to be upbeat. Everything has to be positive. People who do very negative talks tend not to get invited back, unless, of course, you're the conference sponsor. So the really good thing about this is that it convinced me to stay up until 2 o'clock rewriting about 1/3 of this presentation, because he let an elephant into the room, and I have to address it. I can't just let it sit, because, frankly, a lot of what he says is very, very valid, and a lot of this echoes what it is that we saw when we went to go ahead and deploy the thing. So the background, one last little story before I get started, which is that when I was first asked to give this talk, I had some guys from the sales and marketing team come over, and they kept saying, oh, this is going to be great, this is going to be fantastic. I said, well, you know what, we have this company priority, which is selling the company out to StackPath going on. I don't really have time. And they said, fine, we'll do it with you. So we sat down and talked, well, what were the problems with this? And my comment that kept coming back after doing a lot of benchmarking, after doing a lot of testing with this is, well, a lot of this is buzzword compliance. So it's sort of being done because customers are asking for it, so we have to do it, but does it really get us anything? Does it really do anything for us? And the guys said, this is great, we'll pitch this in, and I thought this was a wonderful solution to my problem, because I'm not allowed to do a negative talk. This is a negative talk. It's absolutely going to get denied, and this gets me out of the whole problem in the first place. Unfortunately, it was accepted. I was quite surprised why, but thanks to Valentin's talk, now I know why it was accepted, is because it has to bookend his earlier talk, because we have to show the entire range of the experiences here. And that's fine, that's fair, that actually works out. So unfortunately, my co-presenters bailed on me about, a month or 6 weeks or so ago, and so I had to, at the last minute, send into this conference, I'm sorry, I have to cancel, I can't do this because my co-presenters are no longer here. And they said, are you sure? Is this non-negotiable? And I said, well, if I can meet my deadlines, get my stuff done, I will be very happy to do the talk. And so I was lucky I was able to do that, and here I am. But that wound up changing the topic to something positive, right? Or at least not negative, which is why the title on the screen says Theory and Practice in NginX Stable. So what I'm going to try to do right now is, I know the clock is ticking, I'm going to try to hustle through a lot of the technical slides. I'm going to try to leave as much time as possible, especially for the QA section, and I'm going to end this with trying to address a lot of the criticisms of HTTP2, because frankly a lot of them are absolutely very valid, but it still has a use case. It still does have a place where it actually delivers value, where it delivers functionality, where it actually does something. I will temper that by saying that when we deploy this globally at Little Mac CDN for our dedicated SSL customers, you basically lease your own IP when you offer a dedicated cert. And so we deliberately set it so that you can either choose to enable or you can choose to disable H2 support, assuming that you have your own dedicated IP. And that was done for positive reasons. We want the end user to be able to make a choice, make their own decision whether to enable it or not. So, all that out of the way, let's go ahead and get started. Technical slides. Again, I'm going to try to hustle through these, so if I skip this and you want to come back to it in the Q&A, that's fine, that's not a problem, we'll do it at that point. So RFC 7540 was ratified, and what wound up happening is, it's a new HTTP protocol. It does basically the same underlying concept. What it's supposed to do is the same thing as the previous protocols, which is to allow the transport of HTTP objects. So you can do requests, you can do responses, and what it was built on was technology from Google called Speedy. In fact, if you go to, there's a lovely backup on GitHub where it explicitly says that, after a call for proposals in a selection process, Speedy2 is chosen as the basis for H2. And that's why, it's a binary protocol. It supports all this other stuff that Speedy did. And it looks really, really similar, and it was built off of that. So Speedy was an earlier Google-defined protocol from a couple years ago, which was designed, again, to help assist the delivery of content and to help pages load a little bit faster delivered from the server, but it doesn't necessarily help other parts of the stack. So I said from a moment ago, we're here to do HTTP objects. Great, what's an HTTP object? Well, you know, it looks like standard any object, and under H2, they're the same as they are under H1. You have the same methods, you have the same request URI, the same headers, the same encodings. It looks the same. And that's good because that's ultimately how we get interoperation. So it has to interoperate with the rest of the web. It cannot break the web. It's worthless as a protocol if it does. So if you look at this from a proxy perspective, I'm a cache, I care very deeply about proxying. What this means is because the HTTP objects are the same, the spec for HTTP forces the object to be idempotent under the get method, which is a very, very fancy way of saying it is not allowed to change. So if I am out there on the public internet, and I am a web browser, if I make a call directly to an origin, I do a GET request for an object, great, I get the object, no problem. But if I go through a proxy server, it's idempotent under the GET method, so the proxy server turns around, does its own GET back to the origin, takes that object and returns it back to the end user. And because it was not allowed to change under the GET method, the object is exactly the same. So the end user doesn't care where he got it from because he's always getting the exact same object. And this is as true under H2 as it is under H1, which is great for me. It allows my business to still exist. But it gets a little bit more fun than that because I can chain together arbitrary number of proxies. So I can bounce this object, and because it's idempotent, under every single one of those, it's always the same. The end user never sees a different object. He gets the exact same thing back. So this is great. I can chain stuff together. The moment I can chain stuff together, I can now interoperate with previous versions of the protocol because each connection can negotiate to a different protocol, and because the object is the same under either protocol, I don't care. I get back the exact same object. So I can interoperate. Now, I can interoperate under load balancing, which is a very standard technology that everyone has been talking about at this conference. It's something EngineX does very, very well. And here's an example where you are using the web browser talks H2 out to the load balancer, but then the load balancer and internally may be talking H1 to some dynamic content servers that may be doing a persistent 1.1 connection out to some static content server, and this is okay. We're getting back the object, everything's getting put together, we look and work the same no matter which protocol we're under. From a practical perspective, from the web browser's perspective. So why do it? What are the benefits that we're actually getting out of this? Well, we've changed now from a ASCII text-based protocol, one where you can just telnet into the port, do a simple ASCII get, you can replicate the headers by hand, get back the expected result, and everything just magically works. That's no longer the case because it's a binary protocol. So my little stupid example is I use curl with H2 support to make a call just plain to netcat, right? Just to see, okay, what's it doing? And you can see, well, it's got all this weird stuff going on because it's got all these weird binary frames it's trying to pass in and all this other stuff under the hood that it's trying to do. And of course, it's no longer quite as easy. On the other hand, because it's a binary protocol, we can do some fun things like do interleave request, we can set request priority, and so we can actually start playing a lot of games that you can't do under H1, in particular the head of line blocking. And this is a very nice point that Valentin brought up the other day, which is that, well, your process can still block, but you can still go through head of line blocking, but within the process itself, you don't get, within the protocol down at that layer, there is no head of line blocking. And a very, very simple example here, H1.1, get, object has to respond, then I can do the next one, object response. So it's a FIFO queue. And you don't have that anymore in the H2 world. I can actually do multiple gets at the same time. While something is streaming down, I can issue another get and start retrieving that at the same time over the same connection because it's multiplexed and interleaved. So it does do some fun stuff. Because we have this interleave connections, all of a sudden we no longer need a flurry of connections to do something. If I have 5 calls, whatever, I only need one connection to do this. And for most end users, they don't necessarily care about this. And you have to get diving into some level of TCP optimization before it starts to make sense. In particular, the discussion about the the congestion windows, and the peril of TCP slow start. I have an appendix slide about it. I'm not going to talk too much about it because I could waste a ton of time on it. But the long and short of it is TCP slow start means that when you start a connection, you're only allowed to send a little bit of data out, and that the longer the connection is and the better and cleaner it tests your connection, the better and cleaner it is, the bigger that window ramps up and the more information you can keep in flight. Which means an existing, already open connection with a huge congestion window can handle a huge amount of information on the exact same line. But if you have a brand new connection and you're stuck going through slow start, you're sipping data through a straw. So in addition to all this sort of interleaving and the like, we have some other fun stuff that we can do, which is server push. And as again, I'm a content provider, I'm a cache. I love server push because what I can do now is if I have a request come in for an object, and on the back end I've done the appropriate data crunching, I know that people who have downloaded foo also want to download bar. Well, I don't have to wait for the request for bar. I can actually push that at the exact same time as I'm downloading foo. So now the browser receives 2 files, even though he only asked for 1. And if I'm remotely clever in the back end, I've figured out what that is. A lot of the current push implementations sort of pre-assume that you know exactly what you're doing and that you can predefine this in your configuration, and it's not very dynamic. This is going to change in the future as this becomes a little bit more evolved. And this is one of the places where a lot of the providers are going to start differentiating themselves and offering a greater level of value. Fine, what else does it do? Well, it also does header compression. Anyone who's familiar with HTTP objects, there's a lot of perils to using custom headers and shoveling huge amounts of data into the header section, because under H1, that's uncompressed data. So all you've done is increase the amount of bandwidth required to download and for what is basically metadata. And if you can hide that or encode it in some cleaner way or some easier way, so much the better. Well, that largely goes away under H2. Sure, it can still be a bottleneck, but because they're now compressed, you can actually start shoveling more stuff in there, not have to worry as much as you did under the previous world. So this should actually start changing the way you can start thinking about a lot of application development, because now you can start making decisions on whatever it is, custom data, metadata you've chosen to shovel into the headers, because you no longer pay such a huge penalty in shipping them around. So again, as a cache, am I happy about this? No, because I bill for bandwidth. Why would I want this? Okay, the real downside to this is that what wound up happening is the formal spec, nobody could agree on whether to force SSL or not, whether to force encryption or not. And so all the browser manufacturers got together and decided, well, you know, we're just not going to support unencrypted H2. So it's a de facto requirement. It is not part of the spec, but if you intend to support it, you have to do it anyway. And again, this makes the configuration a little bit difficult, a little bit different, because now you're stuck dealing with the SSL even for pictures of cats or other things which may not necessarily require SSL encryption. And it gets a little bit worse than that, and I quote from Mozilla here, and you can read that yourself, of course. It's not only that Firefox will only be implementing H2 over TLS, along with the other major browsers, but if a server negotiates H2 with a lower TLS, lower than 1.2, it is treated as a protocol error. So now you can't support TLS 1.1 and expect your Firefox users to be able to negotiate an H2 connection to you. No, that's a protocol error. And of course, it's going to be different per browser. Some browsers will let you do it, some won't. Now, it gets a little bit stranger than that is because in order to make this whole thing work, so back in the Speedy days, Speedy implemented something called NPN, Next Protocol Negotiation. That'll be the next slide. And unfortunately, that's bundled support is in OpenSSL 1.0.1, but H2's unhappy with just NPN. And again, that's not part of the spec. It winds up being one of the browser manufacturers has decided that they want a different protocol. Why is this a big deal? Well, most Linux distributions, like Red Hat, CentOS, even CentOS 7, if you run with that, well, it ships with OpenSSL 1.0.1. So, you know, your pre-built or custom-built version of NginX may be built against an old version of OpenSSL, and thus lack the needed ALPN support, which HTTP2 de facto requires for some browsers. So NPN, Next Protocol Negotiation, it has a very noble beginning. One of the problems is it was absolutely recognized SSL has an overhead. It takes a while to negotiate it. And the goal was to remove a step in the protocol negotiation by moving the Next Protocol Negotiation into the SSL handshake itself, thus saving at least one, possibly more round trips. So this was done for performance reasons. It's not just we felt like throwing in additional complexity for the sake of it. So Speedy, the earlier protocol, relied on NPN to do it. But when H2 came along, it was recognized that the scope was way too narrow for NPN. It only applied basically to well, speedy in this case. And what they wanted was something that was much more general, that you could apply to any possible application that may choose to use this in the future. Hence, application layer protocol negotiation, which is what ALPN actually stands for. And up there, I just have the abbreviated handshake real quickly just to show how it is that it's working. So again, there's the RFC associated with that is in there, so when you look at it, and since I know that a lot of people will be just looking at the slides later, I included the support matrix just to keep it clear. You need the newer version of OpenSSL. All right, so now some of the practice. That was enough of the theory, that's kind of what it does for us. What about the practice? When we go through to actually do this, especially inside of NGINX, what are the implementation particulars, what are the gotchas, what's actually going on? Part of it is speedy support is now gone. This is not intrinsically a bad thing because Google itself deprecated speedy support as of May. So for all the newer builds of Chrome, well, they don't do speedy anyway. It's not that big of a deal. There are other H2 implementations in which speedy can coexist. Again, it comes down to the NPN and ALPN thing. You can negotiate to the other protocols, but NGINX doesn't. That's fine. With H2 enabled on an IP, it's enabled for all server blocks assigned to that IP, which is why from our perspective with our dedicated IP service, that was a big deal to us, and that's how we can control whether we allow it or disallow H2 access, assuming you have a dedicated IP. If you use a shared IP with us and use a shared cert, too bad, too sad, you're getting H2 whether you like it or not. So NGINX 1.10, the mainline does not currently support H2 push. It might in the future, bug the NGINX guys, but currently it doesn't. And what is of most interest here is the fact that mod proxy does not support H2. And this is one of Valentin's points in his talk yesterday, which is an excellent, excellent point, and that it may not necessarily ever support H2 because it may not necessarily make sense. So just bear that in mind. Real quick digression, if you want to know that you are testing, how do I know that if I want H2 that I'm actually getting it? How do I test for it? If you want H2 support, you require a newer version of curl, 7.34 or newer, and once again, build it against the newer OpenSSL, otherwise it can't do ALPN negotiation. If you're using a web browser like Chrome, if you use the developer tools, that also displays which protocol it is that it's negotiated, so it'll tell you if it's got H2. And of course, NGINX itself will log this, so if you look at the common log form, sure enough, and I have it highlighted in blue, it actually tells you, yes, I did get an H2 connection, and I wrote it down right here. Fine. Another side note, what happens if you cannot negotiate an H2 connection? Well, you downgrade gracefully to H1. Once again, you're not allowed to break the web. This has to have some method of interoperability, so the failure mode of H2 is that you just downgrade. Sure, it may take a little bit longer, but whatever. It still works. You still get your content. It does not break. So I'm going to show some results of doing some very, very basic, simple benchmarking. It's sort of comedically simple, and it's here to make a big point about this. And so I'm just showing you what it is that I've done. I'm actually, enable SSL, enable the v2 module, fine. So this little benchmark is run on this little MacBook Air. If your app has so few users and so little traffic that you can actually host it on a MacBook Air, then this benchmark probably does not apply to you. I did this deliberately, so I want to emphasize this is not simulate your app. It does not simulate a real-world production environment. It's very deliberately a limited environment, and I promise the point that I'm trying to make out of this is going to pop out, and it will be really, really clear once we actually start looking at some of the results. And this is only going to take another second. I just want to emphasize again, when you go and do this sort of benchmarking yourself, chances are you're going to get a different result because you're going to do it on a real server, not in your little MacBook Air. So all I've done here is I've configured 3 little server blocks. One is unencrypted H1, one is encrypted H1 using TLS 1.2, and one is H2, right? So the benchmark I'm using, real simple, H2 load. It comes out of the HTTP2 project. It's really simple. All it's doing is opening up a connection, making a request, in this case for a 100-byte object, again, stupid simple, and it asks for it as fast as it possibly can, and returns back and measures, well, how many did I get back within a given period of time? In my case, I'm just asking for 50,000 of the exact same object, one after the other. So fine. What does H2 look like? And again, deliberately limited benchmarking environment. This is not a real-world test, but I want to point out to do 50,000 objects finished in 3.67 seconds, I'm pushing 13,600 odd requests per second. If you look at the mean time per request, 68 microseconds, it's okay, it's not too shabby. And what I want to point out here is that in this benchmark, it says that space savings is 36%. Again, you won't see this in the real world. This is because I have a 100 byte object. So if I'm able to compress my headers down, my headers are actually a very reasonable percentage of the total object size, and that's why that number is so high. But it's here to show that, yes, the header compression really works. It really is doing something. So, drum roll, please. What if I only want to hit it with HTTP 1.1, again, TLS 1.2, exact same setup, exact same object, exact same little testing environment, and all of a sudden I finished in 2.97 seconds? Well, that's weird. So if you look at the mean, all of a sudden I'm down to about 58 microseconds time for requests as opposed to 68, and I can push, 16.8 thousand requests per second versus the 13.6 thousand I was doing in the last benchmark. So Valentine's point was spot on. H2 actually does have additional overhead, especially on the server side, and that can slow you down. It really is there, and we can see it in the actual benchmark. And this is why I wanted this limited benchmark set, because now it's comedically obvious that there really is a difference there. So you have to be careful. This is not a magic make it go faster button. So, but it gets a little bit more interesting because, well, let's take a look at what unencrypted does. If I make a plain old H1 unencrypted connection, now I complete in 2.3 seconds. I'm pushing 21.7 thousand requests per second instead of 16.8 thousand instead of 13.6. So not only does H2 have an overhead, SSL also has a major, major overhead that can be very, very substantive. And look, now my mean time for requests is down to 45 microseconds, right? So this expands. You can see it. You can see it. It actually is here. And you have to be very, very careful for your use case that, one, you have to make sure that you need the de facto requirements of H2, which is SSL. You need to know that you have to be able to utilize the actual use cases that H2 provides, that header compression has to make sense for you, that you can handle the interleaved requests. And you can't just assume that everything's magically going to go faster just because you've enabled it. So you really, really, really have to keep in mind that there is a cost associated with this. You better make sure that the benefit that you need is there in order to justify doing it, which is why at Little Mac CDN we're very careful to make sure that this is user-choosable option. And we trust the end user to be smart enough and clever enough to have done their own benchmarking to know whether or not it actually works for them. So it affects both throughputs and latencies. So one thing I really want to emphasize here is that engineering is always done with numbers, right? The moment someone comes out, I think this, I think that, well, that's great, but that's opinion. You need some sort of numbers. So you really need to take the time to understand what your app is doing. You need to take the time to benchmark, make sure this actually works for you. You really, really have to optimize. You really have to make sure that you're playing to its strengths. If you can play to its strengths, like header compression, it's there. It will give it to you. But you better make sure that that's the use case that you're using it for and it actually works for you. So if you look a little more globally in terms of future-proofing of this, H2 is not going away, right? I mean, now it's been ratified as a standard. It's going to be there. The reference implementations are out. It's now been pulled into EngineX and other mainline, very common. It's pulled into Apache. And so support for this is basically uniform. It's across pretty much everywhere. So the protocol itself isn't going to disappear. So you need to make sure that it is working correctly for you. The last thing I wanted to mention in terms of future-proofing is you notice that it reduced the number of connections. If you are an app developer, you probably don't care so much about this because this is your really your SRE's responsibility, making sure there's enough compute resources available for it. That's not really your problem. But if you are in the SRE role, then I as a cache, I adore this. I'll run a server with 50,000 simultaneous connections, 100,000 simultaneous connections, not break a sweat. If I have a protocol which reduces that down to 25,000 to 50,000, well, that's a major benefit to me, right? Maybe not to you, but it certainly benefits me. So, this is going to be a lot of pros, a lot of cons associated with it. So you have to be very, very careful in evaluating it. You cannot just push the button. So that's sort of the technical point. I promised, good, I still have a little bit of time here, because what I wanted to do, let's go into some of the criticisms. In the academic world also, there have been some criticisms of the protocol itself. There really is a thing called the second systems effect, and this has been noted by a lot of other guys. I'm just ripping off from Wikipedia here, right? The tendency of a small, elegant, and successful system to have elephantine, feature-laden monstrosities as their successors due to inflated expectations. This is unfortunately very common. IPv4 versus IPv6 is left as an exercise to the reader, but this is absolutely something that we've seen in the past. And there was a gentleman by the name of Paul Henning. He is one of the developers behind Varnish, one of the competitor products to EngineX, and he wrote this letter, and it got published in the journal of the ACM. So this is very high up in the academic world. It's about as high up as you can go publicly in the academic world. And he has this wonderful, wonderful quote, which I've just ripped off shamelessly. H2, the IETF is phoning it in, bad protocol, bad politics. The part I love is that last sentence says, uh-oh, second system syndrome. If that sounds underwhelming, it's because it is. So there are very legitimate complaints about what's going on with this. And again, I have to go back to my earlier comment that you have to benchmark, you have to know it's right for you, you have to know that the use case works for you. I'm not that cynical. And the reason why I'm not that cynical about it is I want to go back to a older concept I'm going to rip off shamelessly from Deming, which is his definition of a system. And his system is a network of independent components, interdependent components that work together to try to accomplish the aim of the system. So Linux, NginX, your network card, well, those are your network of interdependent components, and they all work together to try to accomplish the aim of the system, which is to serve out a web page, to serve out an HTTP object, right? So that sure looks like a system to me. And if I have a system, then I can apply theory of constraints. What's theory of constraints? Well, a guy named Dr. Goldratt came up with this, wrote a book about it in the 80s, and it had spent a long time with it, but it's a methodology for identifying the bottleneck. And what theory of constraints says is that given a system and you're interested in performance, you're always looking for the bottleneck. You're looking for the slowest part of the system. Then you go alleviate the bottleneck, you rerun your benchmarks, find out where the new bottleneck is, lather, rinse, repeat. And you continue this iterative cycle until you get something that meets your minimum specified criteria. Also known as the Shewhart cycle, right? Plan, do, study, act. You plan, I think the bottleneck is here, you alleviate that, you study, did it actually work, and act. If it did, great, move on to the next one. If it didn't, then I have to review and go back and replan how I'm going to affect this particular problem. So is H2 the bottleneck in your system? And that's where you're stuck. You have to do the benchmarking work. You can't just take my word for it. You can't take anybody else's word for it. You have to make sure that you are playing to its strengths, that it works for you. You have to put the legwork in on this one. You cannot just phone it in. So to go back to the very, very first story that I started out with, as I said, I was supposed to give this talk with a couple of other gentlemen who unfortunately bailed on me. What they were really interested in doing when we sat down to talk about is we talked about how H2 was probably was a feature that a lot of customers were asking for, but in our own benchmark and testing, we didn't really see a major benefit to doing it for most people. On the other hand, it didn't seem to cost us an awful lot in order to offer it, which is one of the reasons why we went ahead and did it, right? We're responding to customer, but we were kind of indifferent, right? It didn't really do much of anything for us. And the problem is, what do you call it when you have this situation and sales and marketing wants you to do something, wants you to add a feature, but it doesn't really do anything, but it doesn't really hurt? What do you call that? Well, that's kind of the definition of buzzword compliance, which was the original topic of the talk. All right. And I think I have left enough time for a reasonable amount of questions. And my expectation is it's going to start a holy war, because stuff like this always does, at least amongst the engineers in the crowd. Yes, sir. No worries. Well, when Mike gets here, let me know.
Hi, Mike. So is StackPath implementing server push? Is that something you guys are going to hack into your offering, or are you just sticking with the upstream?
We're talking about it. For the initial product launch, the answer is no.
Okay.
So do you think in a reasonable time you could have come up with a benchmark that would have actually demonstrated the performance improvement of HTTP2, let's say, by interleaving?
Yes, yes, sir. That's an excellent point. You're absolutely right. Yes, absolutely. Through interleaving and the ability to do multiple requests over one connection, you're absolutely right. It's totally possible to come up with a benchmark that does that. I didn't for the obvious reason. I was trying to show the difference there, but you're absolutely right. There are such benchmarks. There absolutely are use cases where H2 outperforms the older protocols, especially under encrypted scenarios.
Actually, a clarification. In your benchmarks, was it a single SSL connection and you were just putting multiple requests on it, or was it like multiple sessions as well?
You're absolutely right, just one connection. And putting a little bit of thought, this particular benchmark is a very, very stupid one because I'm asking for the same object over and over. So even if I tried to interleave these, it didn't matter because it was the exact same object. So it looked the same if I was requesting 1234 or 1324. What? Nobody wants to argue the criticism of the protocol? I can talk more about it if you like. I mean, it's not just Mr. Kemp who has brought up criticisms of it. Yes, sir.
So for the batching of multiple requests into one connection feels like it would have a significant improvement on the performance for the SSL side. Is that what you would expect in an actual deployment, in a CDN deployment, or would you still expect that the number of connections required would still, for other reasons, have to go large?
My expectation is that the number of connections is going to decrease, and that therefore I should have more CPU and other resources available to handle the encryption overhead. But a lot of this comes down to systems design, because the moment the connection bottleneck is alleviated, I can start to afford to spend CPU resources and other things. Ideally, I can offload even encryption from the CPU that will result in lower latencies, which is ultimately what I'm very, very deeply interested in. So I want to get to the point where I can run incredibly high clock speed CPUs with a minimal number of cores. And I can do that if I can offload the SSL operations to a secondary card. But the reason why I want to do that is now I can, so TCP, the packets come in, it's basically a queue, and the faster I can pull things off of that queue, the faster I can satisfy the request, the lower my total object latency time is. And unfortunately, that correlates very, very tightly with CPU speed, not so much with the number of cores that I happen to have. So that's sort of the area I want to go into. CDNs largely compete on latency. That's sort of why we were expecting people to use us. That's sort of our value proposition. So anything I can do to increase even a millisecond is a major, major win. Yes, sir.
Yesterday it was mentioned that one of the criticisms was you can still have head-of-line blocking in HTTP2, and I'm wondering if you can explain the difference, or what he was mentioning there versus no head-of-line blocking that the protocol is supposed to.
That was an excellent point, and one of it is NGINX has worker processes. So I'm sure Valentin can fill in more details if I get something wrong. But you have multiple worker processes. That worker process now has to handle the HTTP2 pipeline. So within that one pipeline, those HTTP2 requests, those can be interleaved. There's no head-of-line blocking within that pipeline. But the pipeline itself can block. So if it's stalled out on something, then forget about it. It doesn't matter how many things are queued up within the H2 connection. Those are all now blocked because the process itself is blocked. All right, if that, oh, sorry?
Maybe one small question here.
Yes, sir. One small answer.
So why many connections is performance problem?
So each connection chews up a fair amount of memory. One of the things that we found, especially looking at comparing different SSL terminators, was that the amount of memory each connection gets reserved. If you have too many connections, this winds up blowing past a reasonable amount of memory assigned to it. So in a given caching server, we have to reserve some amount of the memory for the actual objects we're interested in, and we have to use some amount for the networking stack. We tend to push our buffers really, really big because, again, we're really interested in performance, and we want to make sure that our server itself, and certainly our network, is never the bottleneck. And as a result, we allow connections, we allow our congestion windows to run up really, really high, and we allow our TCP windows to go incredibly, incredibly big. And unfortunately, that just chews up constant, huge amounts of memory. And it correlates with the number of connections. So the fewer connections we have, the less memory we use. The more connections we have, the more memory we need.
So it's about memory, it's about cache?
Well, those are the same answer, right? Because we use it for both purposes.
And maybe another small question here is, when you talk about encryption, you talk about symmetric encryption. So modern processors, they do have specialized instructions for that. Why do you think that specialized card will do better?
So one of the things, you're referring to the Intel's AES-NI instructions. A little quick side story about that is I've actually taken receipt of servers which for some bizarre reason had the AES-NI disabled in the BIOS. So I've actually made the mistake of putting in servers which I thought were configured correctly but came from the manufacturer incorrectly configured, and was wondering, why is my CPU load so high? What's wrong with these servers? And it took a little bit of diving down into it to realize that the reason why was the AES-NI instructions had been disabled. And enabling that, very luckily, was able to bring our CPU load back down and to line what we were expecting to see. So when you start looking at, currently there's a couple competitors in this space for the SSL offload boards. Intel has one. There's other companies like Cavium which have them. And when you start doing evaluations of these, the promise of these boards is the ability to do not just offloading the encryption overhead from the CPU, but you can also do other things. You can do like compression, and you can play some other games with these things. And the idea being, once again, we have a queue. We have the content request comes in, it goes into a queue, it has to get satisfied, it goes back out. And anything that we can do to decrease the cycle time of this, to increase our throughputs through that queue, is of tremendous interest. So that's sort of a very broad answer to why we would be interested in looking at a card. Oh, sorry, there's one over here, then we'll come back over here.
Are you guys using H2 to deliver videos, and if so, like what's the performance like?
Excellent question. So I'm going to talk from the Mac CDN side, from the legacy business, and that absolutely it's used to deliver largely negotiate either HLS or HDS content. So we're not using it for a lot of others. Little quick side note is at one point we took advantage of NginX's slicer module and wrote a little package we call Ranger, which is designed to assist with video delivery by taking up a very large video MP4 file and slicing it into smaller chunks, which we can then deliver, and taking advantage of range requests. So from that perspective, we haven't really noticed a major, we're not getting complaints about it. When you actually start hitting it with benchmarks, it performs well enough that it's not the bottleneck. So again, the protocol here, at least for us, is not yet the bottleneck for this. We have bottlenecks elsewhere within the system. So we haven't really noticed a difference. Yes, sir.
So obviously, it's trivial to look at the H1 wire protocol through just Netcat or TCP/NUP or something like that. Like you just read the ASCII protocol and see what's going on. You can't do that with H2 because it's binary and because it's encrypted, because browsers are forcing encryption. Have you guys done any work on like building Wireshark plugins or doing any custom work to do any wire debugging for your inbound traffic?
Excellent question. We haven't monkeyed much with Wireshark for that particular purpose. Obviously, we use it elsewhere tremendously. However, there are ways, if you have the key, then you can go ahead, and there are ways to use Wireshark to use that key to go ahead and decrypt the contents that are contained within the packet. In practice, as just a little side note, when I'm using Wireshark, I tend to, if I'm doing a TCP dump, I tend to set the snap length really, really tiny because I actually don't want the content. I'm trying to find out what's the metadata, how is it actually performing, am I dropping packets, where is the delay actually occurring, am I getting timeouts, and so this is, fortunately, metadata is not encrypted, and so that stuff I can actually read. But no, we haven't played much with it yet. I believe I have 1 minute left, so I think that's enough time for one or two more questions. So I can hold myself to a fast answer.
Hello. A lot of HTTP queries go through transparent proxies on the internet from various services. Do you know which percentage of those might support HTTP2, or whether that's a problem? Will it result in a lot of downgrading to HTTP1?
Excellent, excellent question. You're absolutely right. That's the way that, in practice, this is what we have to do with NGINX is, yes, if NGINX is that transparent proxy, you can only do H2 on the upstream side. Mod proxy is 1.0 and 1.1 only. So you're absolutely right. There will be a lot of these games going where we have to switch the protocol version. But luckily, since the object is the same, we can bounce it across the protocols. At least the end user still gets the exact same content. He gets what he requests, but you're absolutely right. It's going to be stuck passing through multiple protocol versions, which means that you have to now optimize for those middle layers as well as for the edge layer. And so when you start looking at how do I want my topology to look like, and how can I take advantage of things like keep lives or you know, again, very big TCP buffers that I can get very, very fast responses between my mid-tier level and the edge, then you know, maybe you can ameliorate some of the issues. But you're absolutely right. You are going to see protocol renegotiations going on, and you're going to see different connections.
Do you have any like numbers to dish up? Like if you had 10 million unique HTTP users, do you know which percentage would actually manage to get HTTP2 from end to end, and which percentage would need to be downgraded?
End to end, anybody who's talking directly to an NGINX origin can negotiate the full H2 connection. So you've actually kind of asked two questions which you're going after, one of which is that what percentage of websites actually offer H2 negotiation right now, and that's surprisingly small. Let's call it 20, 30, 40%, if that. This is from Google statistics. However, the other question that you're asking is if I can go end to end, because CDNs are so common and serve so much of the world's traffic. In practice, the answer is very, very tiny percentage is actually fully end to end, because most guys are flowing through a transparent proxy. And there you can only do, or for most guys, you're only going to be able to do the H2 termination from the edge on. Everything else internally is going to be H1.1. I'm sorry, my time is out. I'm very happy to continue questions. I hope that you'll find me after this, and I hope that you'll have a wonderful day at this conference. Please, please, please continue the argument. Very, very happy to keep talking, and we'll kind of go from there. Thank you.